Hey guys, so today we are going to learn how to do calculations for energy flow through trophic levels in an ecosystem. Okay, so let's just jump into it and get started. Here we go. So you have here two formulas that we're going to use. Okay, so this first one over here says NPP equals GPP minus R. So what does all that mean? So GPP is gross primary productivity. Not gross as in disgusting, but gross as in total or whole. Okay? Productivity. And then R is for respiration, as in cellular respiration. And then NPP is net primary productivity. So basically, is the producers in this ecosystem, how much like photosynthesis are they doing to create like energy and biomass, minus what did they use for their own cellular respiration. We're going to get the net primary productivity, like what's available, what's the energy available in this ecosystem to support a food chain or a food web. Okay, and then the efficiency of the producers is going to equal the NPP, their net primary productivity, divided by the insolation energy. That's just the energy from the sun that's available to them, times 100. This is just a plain percent equation. So part over whole. So when we compare the total amount of energy from the sun that's available to these producers, okay, and then the part that actually is available to like be eaten, okay, what's the efficiency of the producers in this ecosystem? Okay, now in the AP exam, you will for sure have a math FRQ. It's like guaranteed. You have 3 FRQ questions. The last one most likely will be math. Okay, so a couple of things you should know. Calculators are allowed, so hooray, that's awesome. A math question or a sub question, and by that I mean like A, B, C, D, whatever, is always worth 2 points, okay, every time. 1 point for the setup, including the units, so you have to show your work, and 1 point for the correct answer. Okay, now here is the thing. For the setup, you must include the math operation and the equal sign and a unit. So I can't just do things like, 2 times 4 equals 8. And I know that for some of you that might seem really silly, but as a teacher, when I grade a lot of stuff, I'm like, how in the world and how am I supposed to know what these floating numbers are supposed to be? You have to put like a multiplication sign and then an equal sign. Like if you do not do that, even if it's obvious that you know it, you're not getting credit. Okay, and don't round until like the very end. So make sure you wait till the very end to round. Okay, so on your notes, as I was looking through these, I was like, the second question really is a lot easier than the first. So I'm going to start with the second question. Okay, so let's just jump into this. A wolf in a simple food web feeds on elk and rodents, which feed on plant material. Okay, so I'm going to do here plants are being eaten by rodents and elk. My tablet here is not working very well. Elk, oops, okay, which are both eaten by wolves. Okay. All right, so there's my little simple food web. Net primary productivity, NPP of the ecosystem, is 60,000 kilocalories per meter squared per year. So if I get a meter squared in an entire year, it's making 60,000 kilocalories, or 6.0 times 10 to the fourth. If this ecosystem covers approximately 10,000 meters squared, what is the total energy in kilocalories supplied to the wolves within the ecosystem in a year? Okay, so I want to see the total NPP for this entire ecosystem, not just for a meter squared. So if I have 60,000 kilocalories, okay, per meter squared per year, okay, and then I gotta multiply this by 10,000 meters squared. And if I look at my units, this is the bottom of the fraction, would be on top, so those cancel out. So I end up with, and I did this math earlier here, and I'm going to use scientific notation, 6.0 times 10 to the 8th kilocalories per year. And I know that when you come out of chemistry, you're like, sig figs. Guess what? No sig fig in APES. So, yes. Okay. So 6.0 times 10 to the 8th kilocalories per year is the energy that is available for the wolves. Okay. At first, this is the NPP here for the entire ecosystem. Actually, that's not the final answer. This is just what's available in the entire ecosystem. As we have learned the rule of 10%, okay, so from plants to primary consumers, we're going to get 10%. And then from primary consumers to secondary consumers, we're going to get 1%, right? You get 10% each time. So, if I do this the long way here, so 6.0 times 10 to the 8th kilocalories per year times 0.10 times 0.10, so 10% each time, right? We're going up a trophic level, only passes on average about 10%. This is going to be 6.0 times 10 to the 6th kilocalories per year. Okay, so that's that. That's how we do this problem. So if this was an FRQ question, and say like you can do this in your head, you know how to do it, you don't need to write the setup, you only wrote down your answer, you only get 1 point out of 2 points. Okay, so you'd have to write this step here and then this step. Okay, or you can just put them all together and get one final answer, but without the setup you only get half the credit. All right, let's do question B here real quick, and then I'm going to pause this video and I'm going to make another video for the first question. A wolf in a simple food web feeds on elks and rodents which feed on plant material. We already did that. If a single wolf can survive on 1.2 times 10 to the 5th kilocalories per year, how many wolves can be supported in this ecosystem? Okay, so let's look at this. I have 6.0 times 10 to the 6th kilocalories per year. Each wolf needs 1.2 times 10 to the 5th. So I'm going to divide this by 1.2 times 10 to the 5th. Now, these cancel out, right? And then I am going to get that this can support up to 50 wolves. So this ecosystem can support a population of up to 50 wolves. Okay? And that's that. So watch the next video for how to do the first problem, in which we'll use those equations that we went over at first.